We've all seen it in movies. A detective arrives at a crime scene. The area is already quiet, clean, and almost staged. They take a quick look around, notice a tiny detail, and suddenly everything is solved within minutes. Real investigations don't work like that. When a real crime scene is discovered, it usually begins as confusion, noise, and uncertainty. Before anything else can even be understood, investigators have to take control of the situation. This first stage is not about solving anything. It's about protecting what is already there. The first officers on scene have one main responsibility: secure the area. This means making sure no one contaminates or disturbs potential evidence. In forensic science, this is critical because of a principle known as Locard's exchange principle, which states that every person who enters a scene will either bring something in or take something away. Even something as small as a footprint, a hair, or a fiber can change the entire investigation if it is lost or altered. Because of this, the boundaries of a crime scene are often larger than expected. Investigators don't just focus on the obvious center of activity. They expand outward, sometimes covering surrounding rooms, yards, or nearby areas. This ensures that evidence connected to movement, entry, or escape is not missed. Once the perimeter is established, movement inside the scene is strictly controlled. A single entry and exit path is often created so investigators don't accidentally destroy or cross-contaminate evidence. Everything becomes structured and deliberate, even the way people walk. At this stage, investigators are also observing conditions in real time. They note environmental details that could later become important: lighting conditions, temperature, weather, smells, and any signs of disturbance. These small observations can help reconstruct what happened and when. Importantly, this is not a moment for speculation or quick conclusions. Investigators are not trying to solve the crime yet. Instead, they are focused on preservation, keeping the scene as close as possible to its original state before analysis begins. Different types of cases also require different approaches. A burglary scene will be handled differently than a suspected violent crime or unattended death. Each situation influences how large the perimeter is, what risks are present, and how evidence might be affected by time or environment. By the end of this stage, the scene has been stabilized, chaos has been contained, access is controlled, and the environment is preserved. Only then can the investigation move forward into the next phase, documenting everything exactly as it was found. Once a crime scene is secured, the next step is not to search for clues right away. It is to record everything exactly as it exists in that moment. This phase is about building a permanent, detailed snapshot of the scene before anything is moved, touched, or analyzed. In real forensic work, this documentation stage is far more detailed than what is usually shown in film or television. Investigators are not just taking a few quick photos. They are creating a complete visual and written record that can later be studied, measured, and even reconstructed long after the physical scene is gone. Photography is one of the most important tools used here. Investigators follow a structured method that begins with wide-angle images to capture the entire environment. These shots show how rooms, objects, and spaces relate to each other. After that, they move into mid-range photographs, which begin to show the positioning of specific objects in relation to the scene. Finally, they take close-up images of individual items that may become evidence later. Every image is carefully documented. This includes noting where it was taken, what direction the camera was facing, and what it is showing. Many of these photos are also taken with a measurement scale in frame, so that size and distance can be accurately understood later in analysis. Alongside photography, video recording is often used to provide a continuous visual walkthrough of the scene. This helps preserve context, showing how a space connects together rather than just isolated still images. In more advanced modern investigations, teams may also use 3 3D laser scanning technology. This allows the entire crime scene to be digitally reconstructed. Investigators can later virtually walk through the scene, rotate perspectives, and measure distances without physically being there. This has become especially valuable in complex or large-scale investigations. At the same time a crime scene sketch is created. Even with modern scanning tools, sketches remain important because they highlight spatial relationships in a simplified and clear way. These diagrams show where key objects are located, often including measurements between them. They act as a visual map that supports the more detailed photographic record. What makes this stage so important is its permanence. Once a scene is cleared, it cannot be recreated exactly as it was. Every object, every position, and every detail recorded here becomes the foundation for everything that follows. There is no rushing, no assumptions, and no interpretation yet. This phase is purely about preservation through documentation, capturing the scene in its most accurate form so it can be studied again and again without distortion. Only after this complete record is made can investigators begin the careful process of searching for evidence. With the scene fully documented, investigators finally begin the process most people associate with forensics, collecting evidence. But even this stage is highly structured and methodical. Nothing is picked up at random, and nothing is assumed to be important without context. Search teams usually follow a logical progression, moving from the most visible evidence to the most subtle. This approach helps ensure that larger, more easily disturbed items are recorded and collected before smaller trace evidence is accidentally altered. The type of crime strongly influences what investigators prioritize. For example, in a suspected break-in, attention may first go to points of entry, like doors or windows. In other situations, focus may shift to areas where interaction likely occurred between people or objects. Every decision is guided by reconstruction, not guesswork. Evidence itself comes in several forms. Physical evidence includes tangible items such as broken objects or materials left behind at a scene. Biological evidence involves substances like skin cells or bodily fluids that can carry genetic information. Then there is trace evidence, which refers to extremely small materials such as fibers, soil particles, or hair fragments that can link a person or object to a location. One of the most important aspects of this stage is volume. Investigators do not rely on a single piece of evidence to form conclusions. Instead, they often collect many samples from different areas of the scene. Each item is treated as part of a larger network of information, rather than a standalone answer. Special attention is also given to impressions and patterns. Footwear marks, tire tracks, or surface impressions can reveal movement through a space. Even when they are not clearly visible, techniques like dusting, lighting adjustments, or chemical enhancement can be used to reveal hidden details. Another major component is fingerprint recovery. Investigators search for latent prints, which are not visible to the naked eye but can be developed using powders or chemical methods depending on the surface type. DNA collection is also a key focus. Modern forensic science allows for genetic material to be recovered from extremely small biological traces left behind through contact. Even minimal interaction with an object can sometimes provide usable genetic information if properly preserved. Throughout this entire process, contamination prevention remains critical. Every item collected must be carefully packaged, labeled, and tracked so it maintains its integrity from the scene to the laboratory. This ensures that once analysis begins, the evidence can be trusted as unchanged from its original condition. By the end of this stage, the crime scene has effectively been transformed into a set of physical samples and recorded materials. The scene itself may no longer be active, but its information has been carefully preserved and prepared for scientific examination in the next phase. Once evidence leaves the crime scene, the investigation shifts into a completely different environment. The forensic laboratory. This is where observation gives way to controlled scientific testing, and where every item collected is examined under strict procedures designed to ensure accuracy and reliability. Before any analysis begins, one rule governs everything: the chain of custody. This is a documented record of every person who handles a piece of evidence from the moment it is collected to the moment it is presented in court. Each transfer is logged, signed, and tracked. If that chain is broken or unclear, the evidence can lose its value in legal proceedings, no matter how important it might be scientifically. In reality, lab work is not fast or immediate. Unlike television portrayals where results appear in minutes, forensic testing often takes days, weeks, or even longer, depending on workload and complexity. Many laboratories handle large backlogs, meaning evidence is processed in priority order based on the seriousness and urgency of cases. Different types of specialists handle different kinds of analysis. Forensic biologists focus on DNA and biological samples, carefully extracting and comparing genetic material. Toxicologists examine fluids and tissues to detect the presence of chemicals, drugs, or other substances. Each process requires precision, repetition, and strict validation before results are confirmed. One of the most detailed areas of forensic science is ballistics analysis. Experts study firearms evidence such as bullet casings and markings left on projectiles. These markings are microscopic and unique to each firearm due to imperfections in the barrel. By comparing patterns under high-powered microscopes, analysts can determine whether a specific weapon may have fired a particular bullet. Digital forensics has also become an essential part of modern investigations. Specialists recover and analyze data from phones, computers, and storage devices. This can involve reconstructing deleted files, examining communication records, or tracing digital activity over time. The process is often slow and detailed due to the volume of data involved. Despite advances in technology, human expertise remains central to all forensic work. Artificial intelligence and automated systems are increasingly used to assist with sorting and pattern recognition, but every result must still be verified by trained analysts before it is considered valid. At this stage, science does not provide conclusions about guilt or innocence. Instead, it produces structured findings, data points, measurements, and comparisons. These results become the foundation for the final phase of the investigation, where everything is interpreted and assembled into a complete case narrative. Once laboratory results are complete, the investigation reaches its final stage: interpretation and reconstruction. At this point, forensic science no longer functions as separate pieces of data. It becomes a connected framework that investigators use to understand what most likely happened. Importantly, lab results do not identify a guilty party on their own. They simply provide verified findings, such as DNA matches, trace comparisons, or digital connections. The responsibility of turning those findings into a coherent explanation falls to investigators and analysts, who must carefully evaluate how each piece fits into the wider picture. A key concept in this stage is circumstantial evidence. Unlike direct evidence, which shows an action outright, circumstantial evidence requires interpretation. For example, a fingerprint or DNA match does not automatically explain how or when someone was present. It only establishes a link. It is the combination of multiple independent links that begins to form a stronger overall picture. Investigators look for patterns across all evidence types. Biological findings may place a person at a location. Trace materials may suggest contact between objects or environments, and digital records may help establish timing. When these separate elements begin to align consistently, they create what is known as a case narrative, a structured reconstruction of events supported by evidence. This process is careful and controlled because interpretation can never rely on a single factor. Every conclusion must be supported by more than one form of evidence. and alternative explanations must always be considered. If an element does not fit the overall structure, it is re-examined rather than forced into the narrative. One of the most important roles of forensic science is also exclusion. Not every investigation results in identifying a suspect. Sometimes the evidence is used to eliminate possibilities and narrow the focus of an inquiry. This is a critical but often overlooked part of the process because it prevents assumptions from guiding decisions. In many cases, forensic evidence also plays a decisive role in court. Jurors are not shown raw data alone. They are presented with expert interpretation that explains how each finding connects to the larger case. This is where clarity, structure, and scientific explanation become essential, because the goal is not just to present evidence, but to make it understandable. There are also real-world cases where forensic science has overturned earlier conclusions. Advances in DNA technology, improved databases, and re-examination of old evidence have led to wrongful convictions being corrected years later. This highlights one of the most important aspects of forensic work. It is designed to evolve as methods improve and new information becomes available. Ultimately, the final stage of forensics is about building a logical, evidence-based explanation of events. It is not driven by intuition or assumption, but by verified scientific results that have been carefully collected, preserved, analyzed, and compared. When all of these elements come together, they form the foundation of how real investigations reach conclusions, not through sudden discoveries, but through a structured process of science, interpretation, and verification.